The aim of the dynamic facade project is the reduction of energy consumption by way of sustainable design while maintaining comfort parameters. The building in which we shall test our design is a public library.
The first step of our project is the site selection. The climate condition that will best suit the dynamic facade concept is the temperate climate. Therefore, we choose the United States of America due to its diverse climate options. We found that the state of North Carolina, which is mixed humid, is the closest to the temperate climate we are looking for. For site selection, we have put certain criteria, and using the ArcGIS Pro software, we implemented these criteria on maps of the state. We put a buffer of 15 kilometers radius from airports and airplane paths to provide a quiet environment to suit the function of the project. Next, to increase the use of the building, we placed a buffer of 3 kilometers radius from universities and colleges. We also looked for a site that is near forests and natural water bodies to take advantage of the fresh air and reduce pollution. Finally, we looked at the main roads to increase the accessibility of the site to the users. After inserting these criteria, the ArcGIS Pro software gave us 5 alternatives, and we chose Raleigh, North Carolina because it is the only option that is urban. As shown in the map, the selected project site is served by different facilities, most importantly, public transportation and main roads. The project will benefit the various buildings in the area such as schools and academies. The library project area is approximately 4,000 meters square. This includes the parking and landscape.
The temperature range shows the temperate nature of the Raleigh City, North Carolina state climate. It is above the comfortable temperature in the months of July to August and below it from the months of October to April. The wind rose of the city shows that the wind comes almost evenly from all directions. The comfort range is between 20 to 24 degrees Celsius and 20 to 80% relative humidity. The library shall comply with the North Carolina Building Code and the North Carolina Energy Conservation Code. The main building materials shall be as follows. The entrance doors with a U value of 0.77 watt per meter square Kelvin shall be composed of 10 cm plywood with ornamental veneer. The windows with a U value of 0.45 watt per meter square Kelvin shall be of metal framing with thermal break and composed of double glazed 8 mm and 6 mm outer and inner window panes respectively and 16 mm air cavity. The roof shall be insulated entirely, walls shall be constructed of regular concrete masonry units, and the slab on grade shall be unheated. The U value for these respectively are 0.032, 0.104, and 0.52 watt per meter square Kelvin. For the kinetic facade, our concept was inspired by louvers and horizontal shades. We were interested in these shapes due to their ability to move at small degrees and control the direct sunlight. We developed this concept into blades that are inserted into a frame so that the blades can close and be raised into a horizontal shade. The mechanism by which the shade will move is by gears to rotate the blades in the vertical axis and hydraulics to set the shade in the horizontal position. The material used for the kinetic facade is plywood treated to withstand the climatic conditions of the area and a veneer to give an aesthetically pleasing look.
The 3 dates chosen for the analysis are January 15, July 15, and October 15. Here we see the sun bath on January 15. And here the sun bath on July 15. Finally, the sun bath on October 15. Here we see the different strategies used. In strategy number 1, we used the horizontal situation of the kinetic facade on the east side, while the west and the south side stayed vertical. On the strategy number 2, we used the horizontal situation of the kinetic facade on the west side, while we use it in the east-south side on strategy number 3. Strategy number 4, we use the vertical situation of the kinetic facade on 3 sides, south, west, and east side. The solar shading analysis shows that the south elevation has the most sun exposure for the longest time of the year. The east and west have an almost equal exposure, and the north elevation has almost no exposure. Furthermore, the second floor roof has more exposure than the first floor roof. This information was important in deciding the location of the PV panels.
First, we see the glare analysis for the month of January. In general, the glare has reduced from the base case to the kinetic case by 6 to 10%. Furthermore, the number of locations where there is glare reduced by almost 50%, where in the base case it was at the windows and the floor, and in the kinetic case it is only at the windows. Here is the glare analysis for the month of July. Here is the glare analysis for the month of October. The kinetic facade has shown improvement in the daylight of the building. In level 1, the daylight factor average has reduced from 3% in the base case to 2% in the optimum case. The daylight illuminance average has reduced from 370 lux to 220 lux. The uniformity ratio has increased from 0.03 to 0.08. In level 2, the daylight factor average has reduced from 4.6% in the base case to 3% in the kinetic case. The daylight illuminance average has reduced from 563 lux to 370 lux. Here are the visual representations of the daylight analysis.
There is improvement in the thermal analysis between the base and kinetic facade cases. For solar gain, there is a reduction of 40% between the base case and kinetic facade scenarios. For the air temperature, the improvement in that the temperature is more within the comfortable range, and there is less load on the HVAC system. This improvement is more clear when we look at the energy consumption. There has been significant reduction in energy consumption for the HVAC system from the base case to the kinetic facade case. The yearly consumption of electricity for the base case was 62 megawatt and became 49 megawatt for the kinetic facade case, which translates to a reduction of 21%. We utilized the second level roof, which is exposed to the highest level of solar gain, by installing solar panels. The result was the generation of 4 megawatt of electricity. This brought down the total energy consumption for the HVAC system to 31%.
For the sustainability assessment, we used LEED to verify the improvement in the building from the base case to the kinetic facade case. In the base case, the LEED rating was gold. This was because the North Carolina building code closely resembles the LEED requirements. In the kinetic facade case, the LEED rating became platinum.